Hello, everyone. My name is Pedro Saleiro, and I'm going to talk about bias and fairness in AI systems. It's a pleasure to be at the SPT Day online, and I want to thank the organization for having me. And I'm a huge fan of the SPT since the beginnings. So, for the audience that doesn't know me, I've been learning data science in many different places. I started at the University of Porto as a PhD student with Carlos Soares. Then I moved to a postdoc at the Center for Data Science and Public Policy at the University of Chicago, working with Raid Ghani. I had the pleasure to participate as a data science mentor at the Data Science for Social Good Summer Fellowship. I'm also one of the co-creators of Equitas, open source, free to use for research and commercial purposes, bias audit toolkit. And now I'm at FITZI Research, working with Pedro Bizarro, and I'm leading the AI ethics research group. And we are doing really interesting stuff around explainability, around fairness, accountability, reproducibility. But today I will focus on the issue of AI bias and fairness. So it's very easy to find news headlines like this one. And you might question what means to be a bias AI. So in this context, bias is about disparate predictions against specific groups of the population. So population that is being hurt based on the model's predictions, because not all instances on our data sets are the same. If we are working with AI in a specific task that has to do with people, people might be defined by different attributes like age, race, nationality, and so on. And these attributes can group people in different subgroups. And bias in this context is about disparate predictions across these groups. And often I get this question, which is if machine learning model doesn't know the race, how can it discriminate? Well, what happens in practice is that it's very easy to infer these attributes like race or gender or even nationality based on other attributes. For instance, in the US, it's very easy to predict your skin color based on your zip code or based on your education or income, or it's easy to predict your gender based on your browsing history. So the model might not be using a feature explicitly assigning people to specific groups, but it can infer these patterns that are specific for certain groups. At the same time, a model that is blind can also discriminate if we think about measuring the impact, the prediction, the disparate predictions, even if the model didn't use or didn't know any information about the attributes or the groups. We can even assess if the model is behaving differently across different subgroups. And we often see in the news statements like this one. This is someone from a large bank that was accused of gender bias, and this is what this person said to the media. There is no gender bias in our process for extending credit. We don't ask whether, when someone applies, if they are a man or a woman. We don't ask if they are married. But based on what I just said, the models can still be biased and can discriminate people based on different attributes. And often we read about bias, and there is this also very common association of the main source of bias being data. For sure, data is a source of bias because data is an artifact that reflects a process in our society. And if the society and the actions and the people and the world is unfair and is biased, the data will reflect those biases. And we can even think about bias in data by thinking about the sample, for instance. Are we sure that the samples that we are using for training and learning our models are representative of the target population in which the model is going to be used? Do we have any kind of label bias? Often is the case that, for instance, in US, there is well-known reports of over-policing specific neighborhoods from specific minorities. And often these people, we have higher rates of arrests because these neighborhoods are being over-policed. So we might also have bias in the labels. The model itself can be biased, can have specific induction bias on how to generalize for new instances, and even all the machine learning pipeline, all the decisions that the data scientists are making are introducing some sort of bias. The way you link different records, the way you impute missing values, the way you group specific features and specific values. All of these steps on the machine learning pipeline, the metrics you define, what you optimize for, what is the point of the ROC curve you are going to deploy your model, all these decisions will introduce some sort of bias. And then there is also the human. If there is a human interacting with the model's prediction, the human can also override specific predictions in a systematic way. So the human might not trust the model in a specific for specific cases, and will encode their own specific unconscious bias in this overriding of the model's predictions. So it's not just enough to say that we have an unbiased model to guarantee that we will have an unbiased impact on our society. At the same time, the actions that are being taken, they may affect different groups differently. Even customer relationship management that doesn't deal with different languages of the population, for instance. There is some sort of heterogeneous effect on the population. And all of these will feed back to data that we collect, and every time we retrain our models, we are creating this feedback loop. And one thing that is also very important to mention is that there has been bias in decision making for a long time. The problem with AI is that we are amplifying, and with the scale and automation, we are propagating bias that maybe before were very specifically located in specific organizations or entities, and we are overspreading these biases with this reach and automation of AI. But it's not that easy to optimize for fairness, because there is no universally accepted definition of what it means to have a fair decision-making process. So different geographies, different people have different notions of fairness. So our role as data scientists is deconstruct a little bit this and try to understand, based on the specific contexts in which our model is going to be applied, to think what types of metrics make sense. But I want to give you a few examples so you think about how tiny differences might have a huge effect on fairness metrics. For instance, if we think of an illustrative example of a model being used to make bail determinations, so basically a model that decides if someone should keep in jail waiting for a trial or not, we might have different notions of fairness in this context. So if the model predicts positive for someone, it means that this person should stay in jail. And so how can we define fairness in this context? So different people might consider it fair if, for people who should be released, the probability of having been wrongly denied bail is independent of race, if we consider race. So this definition has to do with the equal false positive rate, and it has to do with labels. So the definition of, in this case, of being innocent or not. And among the innocent people, the probability of having been wrongly denied bail is independent of race, meaning that people from different groups would have equal false positive rates. But other people might consider that fair is a system that among the jail population, the probability of having been wrongly denied bail is independent of the race. So for all the predictions that were above the threshold in our model, the probability of having a false positive is independent of race among all the people that were predicted as positive. And this is known as equalizing the false discovery rate, or some people call it error rate, which is 1 minus precision. So you see, two different definitions have very different dependencies. If we think about, for instance, the threshold that we choose in the ROC curve will have a huge impact on the number of predicted positives. And the number of predicted positives will be the denominator of the false discovery rate. The other definition of false positive rate really depends on the labels on your samples and the prevalence of your groups. So it's very tricky to define which metric makes sense. But we believe it is possible to narrow down the decisions about which metric we should focus on, thinking about the action. So what action is being taken based on the model's predictions? And this is a concept often defined as impact fairness. So it doesn't really matter what features the model used, what information it was used. What really matters is if the model is making errors that are different across different subgroups. And in this context, different types of actions will have different types of concerns. So an action like the illustrative example of keeping someone in jail, we can say this is a punitive intervention. But an action of getting credits to someone or admitting someone in college is an assistive intervention. So we are providing a benefit. So in the case of the punitive actions, our concern are false positives. And in the case of assistive actions, our concern should be false negatives. So often, because there are lots of trade-offs in fairness metrics, and I'm not going to discuss them in depth today, but there are some metrics some goals that you cannot achieve at the same time. But we can have some sort of relaxation, and if we think about what action is going to be informed with the model predictions, we can narrow down which metrics makes more sense to care about. And now I'm going to show you, because often we have these very vague discussions around bias and fairness, and I want to show you a specific case study. So this is a project I worked on prioritizing early diabetes screening. So we had data from 1 million patients from 2006 to 2018 from the south side of Chicago. And our label in this predictive task is the diagnosis of type 2 diabetes in the 3 years period after a patient visits the doctor. So for every visit to the doctor, we went to the data and we looked for the next 3 years. And if we find a type 2 diabetes diagnosis, this is a positive case, a positive instance. And the action that is being informed by this predictive model is we want to give people access to personalized preventive health care, but we want to prioritize to people that are more at risk. So the people with higher scores are the people that really need help, and we want to prioritize for these people. And this is a case study on fairness-aware model selection. Our performance metric is recall, because once again, this is an assistive intervention, so we optimize for people that need help. So basically, we want to get as many type 2 diabetes diagnoses in the future as possible in the higher range of scores. Our group metric is false omission rate. because our concerns are false negatives, and in this particular project, we were concerned not about false negative rate, but about false omission rate, which is from the all predicted negatives, so from the all people that were predicted as low risk of developing diabetes, how many of them were actually high risk, how many of them were a false negative. And the protected attributes in this project were the age, the race, and the sex. And our test set comprised 200,000 patients visit to doctor during 2014, and the prevalence was 3.4%. So we started with analyzing the current medical practice. So doctors were deciding when someone should be screened for diabetes beforehand. And we started to consider this as a baseline predictor. So whenever a doctor decided to screen someone, we consider this to be the human expert model. And we decided to break down the predictions of these human experts, the doctors, by subgroups for false omission rate. And mostly in terms of disparities, the higher disparities we get is on the age category. So we are missing more people that develop diabetes in these two age groups. And we are somehow discriminating Native Americans and Native Hawaiians when comparing with different ethnic groups which have a lower false omission rate. And here are the range of results for our models. We are here zooming into more than 1,000 of models that we trained, and we are basically breaking down them by different groups and different feature groups. And we can see a trend that on the x-axis we have the global performance, and the y-axis we have the group-wise specific false omission rate and the group-wise false omission rate disparity. And we can see that there is a positive trend on, as we get to models with better performance, the false omission rate tends to go lower, but the disparities are still somehow high on the most performant models. So diving in, we now are comparing the baseline human expert model with our model with highest performance. And we can see that the machine learning model in generally outperforms the ability of predicting if someone is developing diabetes for all the groups. So for all the groups, the model is better than the human expert, but the disparities are slightly different. We can see that the model, especially on race, has some different values for group. And these can be optimized. So we look for the model with the best disparity across the groups defined by the race. And now we have this mustard model. This mustard model, as you can see, is very equal across different groups, but has lower ability to predict people at risk of diabetes. So the trade-off now is, this is an assistive intervention. We are providing something that will help people. We have a model that is very efficient, but has some higher disparities. And we have another model that is slightly worse than the most efficient model, but it's much more equitable. So the question now is, do we sacrifice the ability to find people at risk in order to foster fair outcomes across different groups? And this is a very tricky answer, tricky question, sorry, to answer. And for sure, data scientists are not the right people to answer these questions. And keep in mind that even if we pick the mustard one, we're already better than the current practice. But we are not as better in global performance as we could be if we pick the model with highest recall. So this is a trade-off. And there is something that I want you to think about as well. So imagine that we put in production these models, and what we really want to change with this predictive modeling in this proactive healthcare is the diabetes prevalence in the society. So you can think something like this. Imagine that this is up to the point we decided to deploy our models, and these were the two different prevalence for these two different groups. And then we deploy our model, the most performant one. And we see that the model is better than the current practice for both groups. Is decreasing the treatment. Of course, this is assuming that the treatment is effective, but we can see that we have a good slope, so we are reducing the diabetes prevalence across different groups. But what is also happening? Well, the gap between the prevalence across groups is widening. So we are influencing the society to be somewhere in the future, in a place in which we have a huge disparity of diabetes prevalence across people that are white and people that are non-white. And probably this is not the society we want to live in. So keep in mind about that. It's not just only about thinking a specific point in time, it's also how deploying that model will affect moving forward. So, okay, we audit the models, we find that there are some biases. So what we can do to mitigate the biases when we find that a given model or models are biased? So the first thing, we can collect more data. We can even create some randomized process to collect more data in term for us to get a better representation of the population in which the model is going to be applied. And this is often the case in many computer vision problems that were biased. They were solved by having more data for specific minorities. We can change the way we pre-process data, the way we arrange data. We can learn new models. We can even try bias mitigation in processing methods. So also the fair learning approaches with constraint optimization or multi-objective learning, and we can try to see if we get a better model. We can also apply some threshold, specific threshold. Even if we train a bias model, we can try different thresholding for different groups and see if in overall we improve our fairness criteria. We can do a more informed model selection, as you've seen in this case study. Across all the groups that have good performance, we can pick different models that have different trade-offs and have different disparities for different attributes. And you can also use fair interventions. So making sure that we have tailored interventions for specific groups that are most at need in the case of assistive interventions. But one thing is for sure, the first step towards mitigation is to audit. This is the old cliche of Lord Kelvin. If you cannot measure, you cannot improve it. So audit is really, really crucial for us to stop being blind about the biases on our models. And that was the initial motivation why we developed Equitas. It was the first open source library that was tailored to audit models for bias and fairness and support different metrics. And I really invite you to visit our GitHub repo. So github.com/dssg/Equitas. Please start the model, reshare, re-forward this library. It's really important that most people start auditing their models when they they are developing AI that is affecting people. It's really important to audit the models so we can create this awareness effect. So the question is, try to think about a recent model you trained, you created, and that had to do anything with people. And do you know the biases of these models? If not, you should definitely spend a couple of minutes trying to use Equitas and audit the models. So you can use Equitas in 3 different ways. You can use the web audit tool. I think it's not for the audience of the SPT. This is more for non-technical people that want to try out for small samples. You use a web audit tool, you upload the data, you get predictions. What you need to run an audit, you need a test set with predictions. We need the label, and we need the attributes columns that define different groups. And then you define which metrics you care about in your specific case. You define your fairness threshold, which is for sure arbitrary, but it's a way of you to defining some bands. And then you are ready to go. And it's the same thing when you use directly the Python library on your Jupyter notebooks. But there is also a command line tool. If you have your models in a database, basically you pass to Equitas the SQL query, and it will fetch all the models, all the predictions. It will calculate all the breakdown metrics, and will upload the results back again to the database. So this is an illustration of that awareness effect that I hope you get as soon as you run Equitas. So maybe usually we select the models based on performance. In this case, probably we would pick the yellow model. That would be the model that we use in production. But as soon as we run Equitas, we have a new dimension. And maybe we can make an informed decision. Maybe the yellow model is a really high bias, so maybe we'll pick this one or this one depending on our specific trade-offs. And of course, this is an oversimplification, this illustration, because you have multiple groups. You don't have just one value for all the groups, but you can think about, for instance, considering an aggregation or a maximum or a minimum, depending on the metric, and you can represent a model with just a specific fairness or bias value. So it's really important for us to be okay with not have all the answers, and the audits will for sure not give you all the answers, but will allow you to raise questions and empirically inform those questions. Do I know the models? If I use this metric, what happens? Which groups are there? If I change the threshold of the model, what happens? And the more perspective and the more factors are taken into consideration, the more informed our decisions will be. So we really believe that the data scientists and all of you have a shared responsibility. It's not just because we are technical people that we should avoid to be part on these conversations. After all, we are the experts that deal with the data, that we do the modeling, we evaluate the models, we try to shed light on the black boxes, so we are aware of the characteristics of each model. So we need to understand the broader context in which the models will be applied. We need to take part in conversations with the stakeholders from the community, from the end users, from the human experts like doctors, judges, fraud analysts. We need to make part of this conversation. And it's not just enough to audit and mitigate in one point in time. This is a continuous effort that we should, if we have a model in production, this should be done continuously, every week, every month or so, depending on regulation and so on. So it's also important to pass a message that methods by themselves are not enough to deal with bias and fairness in AI. This is not just something that we love machine learning. We love to define an objective function and we optimize for it. Often this is about having conversations with people, with different stakeholders, and it's more nuanced than that. So we actually need these frameworks. So we think the one that I mentioned before, is the action being punitive? Is the action being assistive? Which type of errors we care about? Making more of this type of understanding around the problems. We need better regulation for sure. And we need external neutral review boards. If we are deploying a model that really affects people, we need some sort of external entities, and it's not enough to go with self-regulation. I have some news. There is a recent book chapter that was released together with Kit Rudolph and Raid Ghani about bias and fairness. I invite you to read. Most of what I present today is discussed there in more depth. It's very easy to read. And also, we have tutorial accepted for KDB, and we are preparing a new release for Equitas. And one thing that we found that is very hard is to visualize these results. The ones I showed on the case study we're using Tableau, but it's very easy to visualize disparities, ratios, values, different group sizes. There are so many different things in place when you are auditing for bias and fairness, but we have the help of the amazing Beatriz Malveira and David Pulido. And they really come up with really, really cool visualizations. And this is joint work with Beatriz, David, Pedro Bizarro, and Raid Ghani, and we are preparing a new release. And I really want to share with you some sneak peeks on that. So I have here a Jupyter notebook, and Equitas is very easy to use. When you go to Equitas repo, you have a tutorial how to use the tool using the Compass dataset. And here I'm also using the Compass dataset, and I'm defining Equitas. As you can see, running Equitas is just 5 lines of code. I'm defining which are the reference groups for each attribute, and Caucasian for race, male for sex, and age category, but we have different ways of defining which are reference groups. And because in the Compass context is about bail determination, so keeping people in jail, we decided to have a look to false positive rate parity and false discovery rate parity. And we start with a summary. And this summary is just to give you an overview for each attribute and for each metric, if the model passed or failed your notion of fairness. And your notion of fairness is this threshold that accounts for how different the ratio between different groups and the reference group should be. In this case, we use the traditional 20%, 1.2 or 0.8. And we can see here for the groups, we can see that we have a reference group, in this case Caucasian. On the right side, we have the groups with the highest values for this metric. In this case, we have Native American and African American with almost 2 times more false positive rates, which is the same that ProPublica reported in the article. When we go to a different metric, then we have different results. So that's also why it's tricky to define different metrics. In this case, the African Americans actually have equal false discovery rate across groups, but maybe what really matters is the false positive rate in this case. And that's actually all the discussion about Compass was about. So I invite you to try Equitas and try to deep dive on these different metrics. We also have a very awesome visualization of disparities in which we can see both the group size, the disparity bands, the fairness bands, and how these different groups compare with this very intuitive way of seeing n times larger than the reference group. So the reference group will always be here. And we can see here that African American is a very large group. So we have a large radius, and we have the 2 times disparity, almost 2 times, as you can see here. And you can do that for see that for the other groups. We also think it's good to know the actual absolute value. So this is a more tricky chart in which we have the false discovery rate from 0 to 1, and we are encoding out the 20% range compared to the reference group in which range of values it shows here. We also have a combination of the 2 charts of disparities and metrics, and then we can select specific groups and see how they behave in different metrics across the line. And at the end, we can also compare 2 different metrics and see if there are different bands for different groups, and see which groups pass for both metrics and which ones just pass for one, just pass for the other. So this is very exciting, and in the next few weeks, we plan to release this new version of Equitas. So stay in touch, and it's going to be a pleasure to talk with you now. Thank you so much.
All right, folks, welcome back. So now we have a chance to ask questions to Pedro, but don't forget that you can use the button that's just like there above me to vote for your favorite question or to write actually any question. So now Pedro is with us. Hi, Pedro. How are you doing?
How are you, Leon? I'm doing great. It's a pleasure to be here.
Thank you. So, guys, I don't know if you actually know, but Pedro is a bit of a DSPT veteran. He gave a talk at the first DSPT meetup in Porto, I think back in 2016. And it was actually the second DSPT meetup ever. Do you still remember what you even talked about there, Pedro?
Yeah, by the time I was working on NLP and about predicting the impact of news articles on the reputation of entities on Twitter, far away from AI fairness and bias, that's for sure. Another life.
So not completely different than what we're talking about here today. Awesome. Well, let's maybe jump right into the question, and like the most popular question by far, I think it's this one. So imagine that you're working in a company that has no machine learning fairness practice established, and you're the one who's building the technical models. What should you do?
So I think it's important for all of us to start to realize that the ML fairness thing is because the field is very new, but I believe that in a few years there is no be any we cannot distinguish ML from ML fairness, because I think thinking about bias and AI and fairness will be part of our daily tasks in data science, will be the current practice. But it's great to start with questions like this one. I think as a starter, for sure, I'd say the first answer I'll say is let's just go to Equitas repo and start trying out the tools. But now, more seriously, I think it's about starting to ask how the model is going to be used in practice. What are the actions that are informed with the predictions? So, as I said in the talk, is this going to provide a service? Is this going to avoid people block some access to services, some kind of punishment? So, first thing is to realize how my predictions are going to affect people, what is going to be the consequences for the people, and then to start do a deep dive on the models, like breakdowns by different attributes. If you don't have explicit demographic attributes like the ones I mentioned in the talk, maybe you can have a proxy and you can extend your data. For instance, if you are using data in US, you can use zip code to try to infer the percentage of different ethnicities in that zip code if the census data is available. So it's really important that data is available for that. But I think it's really to start asking questions, to involve all the stakeholders in the company, and don't be afraid. I think it's a good thing for companies to start looking for these, and that can actually be a value proposition. So don't be afraid to start to asking your colleagues and raising these questions about AI and fairness.
I think there's also another side to this question. Is one thing is where do you start on a technical point of view, what do you do, but how would you go along convincing, let's call it the upper management or something like that, that this is actually important?
I think upper management, as soon as they realize if something is wrong, they really care about things. So it's really about, if you find something, as you'd find any issue in your job, if data collection, if you have a missing feature in production, you'll escalate the problem. So I think we should approach the question about bias and fairness in the same way. It's really important to start with the transparent kind of a communication, even from us upwards, and see how the upwards react back on this. And I am for sure very optimistic about how management will react to this.
So then the next question, it's also, let's say, quite of a panorama / general question. It's what is your best guess on the current fairness practices in the Portuguese industry?
Well, the only feedback I can give is based on the talks that I give at the SPT, for instance, and there is lots of engagement of people. So I think there is this curiosity and interest from the practitioners. I'm not very well informed in terms of the management and prioritization of how the industry is doing. I can just, and we cannot promote right in this conversation, but I can just tell that at FeedZai we have a whole group dedicated to these, and we have practice across all the data science teams. But I'm not sure about the other companies. But I know that the practitioners, they care about these things. So the tools are available, they are free. So I guess there is no barrier for data scientists in other companies to start looking at this.
So you think from your point of view, it's more a question about actually people finding out about these tools and that it's a problem rather than actually.
Yeah, I think it's a very good question. I think it's a question of prioritization.
Okay.
So usually people they have some tasks assigned, they have their mission, and what has been happening, and I think this is unconscious. It's not something that for it's on purpose that people are disregarding fairness. People are just not aware. So if we think about explainability as we are discussing today at the SPT, so even people are not for sure the model behaves. So we still live in this black box paradigm. So bias and fairness is one of the characteristics that we want to open up the box and try to understand what is going on. So I think it's the same kind of effort that we should put bias and fairness in the same kind of shelf as explainability. So it's more of an awareness and lack of prioritization than and and for sure lack of tools as well. But I think we are coming up with more tools that are easy to run the audits.
That's a very great insight. Thank you so much. So now we'll jump to a bit of a different question. Let's call it a bit more technical, so to say. So this is a very specific actually question, but there it's two related. So maybe I'll just first give a bit of background. So one question goes like, how can we investigate systematic racial bias, for example, imprisonment, racial imbalance, if there is no data available? And how would you go with that?
That's a very good question. I worked on criminal justice projects in the US, and in the US, this data is available. And I think I want to have this opportunity here to say something about the Portuguese reality. I know that there has been an effort about COVID-19, about the lack of transparency and sharing of data. I think in Portugal, we are still very opaque and we don't have often breakdown statistics of different groups, even in universities. If you want to know how is the gender trend on applicants in engineering over time, and you go to universities, if you want to know even in the census data, and there is a lack of transparency in terms of sharing these numbers in Portugal. That's for sure. But in the case of the US, in which this data was available for our analysis, it's not as simple as having access to data. Because what happens is that you have an arrest. And this person has attributes, as I said, like sex, ethnicity, age. You can add other attributes. So, but how do you know if that label it's bias? Is a process of a bias process. So the best thing you can do is to look to overall macro statistics, try to understand how the prevalences of these groups compare with the prevalence in the population. Because often what happens is that this data that you have on criminal justice system is just a reflection of a biased process in the society.
Yes, right.
So then it's more about going with in-depth analysis and not so much about trusting the labels, because the labels are for sure in this problem of systematic bias in criminal justice they are noisy for sure.
Okay, so maybe just a really quick follow-up question, actually also coming from the public, and it has to be really quick because I think we're already running practically, it's 0 minutes, but I think we're 1 minute, okay? So this is a thing, but it's still, I think, important to ask. So the question goes like this. Imagine that age and race are variables with real influence on the incidence of diabetes. For example, that in a medical terms, it is proven that older people have a higher incidence of diabetes, right? Or that Caucasian people have a higher incidence. Should we still give up on models' performance in the favor of AA fairness?
So that's actually a question that I believe there is this underlying misconception I mentioned in the beginning. I think we should use these attributes because these attributes are some sort of representations of this systemic behavior in the society. So as I said, prevalence in different age groups, prevalence in different ethnicities. This is a process of how the society and discrimination society is, because there is a proven record of high weights and diabetes prevalence in low-income African-American communities in the US. So it's not about not using these attributes in the analysis. It's about once you have a model and you are applying the model and you want to help people, is the model missing people that need help from different groups? So what is your recall for each group? and you want to optimize for this recall or any other type of metric that allow you to balance for not missing people from a specific group that need help. I think that's the main message that I want to.
Thank you, Pedro. Thank you so much. I'm looking here at the list of questions. There's still a lot of questions. I would encourage. You're on the platform, I guess, Pedro.
Yes, I am.
I would encourage you guys to write maybe these questions to him on the platform, and we'll try to get to as many as he can.
That would be a pleasure.
And thank you so much for this talk and this question. And we'll see a bit in a debate. So just to wrap up, also, Pedro, you said there's going to be a new version of the toolkit. So what do you think about a workshop for data science community in August?
I think that's a great idea.
Perfect. Then we have you on the hook because this was recorded. All right. So thank you so much, Pedro.